But if you want, I can start, sir, actually.
Yes, we can start, and in between, whosoever is there, I will join.
Okay, okay, okay. Let me give some introduction. A very good morning to everyone. I am Bishwit, the president of IIT Guwahati SP student chapter. On behalf of this chapter, I warmly welcome you all to today's webinar on geothermal well integrity and digitalization. We are delighted to have students, researchers, faculty member, and industry professionals joining us today. Before we begin, I would like to share a brief introduction about IIT Guwahati. The Indian Institute of Technology Guwahati is one of India's premier technical institutions, ranked 8th in engineering and 10th in research in the NIRF India ranking. Established in 1994, the institute has rapidly grown into a leading center of academic excellence and innovations. And it is currently ranked 344th globally in the QS World University Ranking. IIT Guwahati is widely recognized for its cutting-edge research, world-class faculty, and strong industry
Recording in
collaboration.
progress.
I would like to give a small introduction about IIT Guwahati SP student chapter. Our chapter strives to create a vibrant platform that broadens opportunity for students through technical, professional, and community-oriented activities. By organizing lectures, workshop, and industry interaction, the chapter aims to bridge the gap between academic research and real-world energy challenges, especially in emerging areas like low carbon technology, sustainable operations, etc. Now, it is our privilege to introduce our distinguished speaker, Mr. Farshad Mirzaei. Mr. Mirzaei is a well-integrated specialist with extensive global experience in oil and gas digitalization and AI-driven integrated solution. He is also a global trainer, speaker, and actively contributing to the advancement of digital technologies for safe, efficient, and sustainable energy operations, including geothermal applications. Sir, we are honored to have you with us today and invite you to deliver your keynote address.
Okay, let me share my screen. Now, you can see the presentation.
Yes, sir, yes, sir. It is visible.
Okay, let's start with the presentation. Hello, everybody. Happy New Year to everyone who is attended this webinar. Actually, and thanks a lot for this IIT GSPS student chapter to arrange this webinar. And Biswait, Mr. Biswait, I know during these holidays it's too difficult to attend any webinar, but I will try my best to deliver some concept to you which worth attending this webinar. As Mr. Biswet introduced me, so there is no need to more details. I just go to the presentation. The webinar is about geothermal well integrity and digitalization. As you can see from the title of the webinar, it includes three main elements, three main concepts. One is geothermal, the second is well integrity, and the final one is digitalization. Uh, just to inform you that in oil and gas industry now, well integrity is the most interested and wanted concept that everybody wants to know about it. Why is that? Because most of oil and gas well are in the second half life of their wells, their life cycle. We have from the first day of the oil exploration, we have more than 5 million wells. Now 1 million is active, which 70% of them are in the second half life. So, and most of them has well issues. So, and if you want to remove this issue or manage this issue, you need to know something about well integrity. If you don't know about well integrity, then your life your life cycle of the wealth will be reduced, and you lose the production, which is high cost. The second subject, the second concept is geothermal, which is very new actually to the world of energy. And I will give you some introduction of geothermal. For sure, this webinar is the time is limited, maximum 1 hour. So we cannot go deeply into geothermal also, but I will introduce you some key points of geothermal energy, why is important, and why will be the trend of geothermal in the future. So the
Recording stopped.
so the combination of geothermal well integrity, which is geothermal well integrity, is the most advanced one subject, which I will recommend this student, because I know a lot of audiences are students. So you can go to do some research on these subjects. I have some ideas to do research about geothermal and well integrity, the new subject, new challenges, and new issues. And also I can support everyone who wants me to support.
Recording in progress.
You can connect me through LinkedIn, and I will be happy to help you. And the final one
Recording
is
stopped.
digitalization. Digitalization uh, is a concept. Actually, if we can look at it, the wall integrity, so it's kind of a barrier. I will explain more, but you can hear about digitalization everywhere. You know, every organization, every discipline, every university, they talk about digitalization, but the concept is something different with what we heard about in media. First of all, let me share with you my well integrity philosophy. Actually, this is my integrity, my own philosophy. I want to make well integrity as simple as can everybody understand it. So I want to go deep into well integrity. This is a philosophy I defined for myself. I will go deep, then make it as simple as you can understand it. Everybody in the oil and gas industry and in other industry, because when a lot of people know about well integrity, it will be more easier to manage it. Because I went through a lot of company, mainly around the Middle East, and I know the same challenges are everywhere. You know, it doesn't relate to the industry, because it relate to people. If people can understand well integrity, they can manage it. It's not related to technology mainly. For sure, technology is part of well integrity, but the main one is people. So if I can train people, if we have good and expertise people, then we can be sure well integrity is okay, and so you can have a safer world and better world. So I will try my best to make the world a better place to live. What's agenda and roadmap? As I said, because we have time limitation in the webinar, I just go through some main concept. First, I want to give you the foundation of well integrity. What is well integrity? What is a standard? What's the concept? And then go to the geothermal introduction. Why is different from oil and gas? So why we should look at as a different discipline? Why we should change our policies? What we should change our technology? We need to innovate some new technology because this difference. Then about some
Recording
challenges,
in progress.
some standards, and then at the end I will go through digitalization, how digitalization will help us to manage well integrity and geothermal. And at the final slide I will give you some recommendation about the future of this industry. I mean both well integrity and geothermal, some research points you can go and find some new subject. Okay, what's well integrity? Actually, well integrity. Someone defined. I don't know who said this sentence. It said the integrity is what you do when nobody is looking. It means well integrity is a system. Well integrity is talking about the standards. Well integrity manage your behavior, manage your organization. There is a lot of standards. When we talk about well integrity, mainly we talk about the standards. Okay, so we don't talk about equipment, we don't talk about technology, we talk about standards. And there is a lot of standards, actually more than 150 standards around the world about well integrity. And in some of them there is some differences. Each one has a definition for this well integrity, which is the main one is Norsec DO10, which is I love it actually. The main one which I focus on is Norsec DO10. For sure, we have a lot of other. We have from UK some standard from UK. Norsec is from Norway. We have someone from API, some Europe standards, and a lot of local regulation. Any country has its regulations defining this well integrity. But based on NORSOC DO10, the well integrity is application of technical, operational, and organizational solution. It's very important. Word by word of this definition is important because this definition will shape your integrity behavior. It's technical, operational, and organizational solution. Technical means technologies, like for example, BOPs, packers, casing, cement, whatever. Operational means procedures. How do you do the cements? How you want to measure it? How you want to install the packer? What kind of casing is better? And the organizational, which is the important one, is about people. People will manage both technical and operational. Solution to reduce the risk. So the main goal, the main reason of any standard is to reduce the risk of uncontrolled release. And you can see also the definition from API RP17N. For sure, it's recommended practice. It's not a standard like NORSOC, but they have difference. Why I put this in a slide? Because choosing a reference standard will shape your integrity behavior. First of all, if your organization wants to go through the well integrity concept, you should choose your standard first. First of all, because based on a standard, you can find what people you need, what training course you need, what expertise and what competencies you need. Then, based on that, your people will shape your procedures, will define your procedures. Based on those procedures, you go to the technologies. So it's very important to choose the standard before going through the well integrity. And if you choose a standard, then during the well integrity process, it is not recommended to change it because as you can see in this slide, the definition is different. For example, API RP needs some prerequisites, which is not from NORSOC DO10. So you can debate before choosing a standard, but after choosing, please focus on that standard and go through it. NORSOC DO10 is life cycle based definition. It means from the first day of planning a well till the abandonment. Then mainly focus on leak prevention. As I said, the reduced risk of uncontrolled release of formation fluids. And this is a strong barrier philosophy. It's based on a barrier definition, which will go through the next slide. From now on, in my slide, if refer to any standard, I mean NORSOC DO10 because I work with it. I love it actually. I recommend it, but for sure, other standard are also the same. If you follow any standard, at the end, you have well integrity. The way is different. The reason, I mean, the goal, the more ultimate goal of all of them are the same, but the way they look at the well integrity is different. As I said, there is more than 150 standard and a lot of local regulation. It's interesting that even to classify the well integrity standard, we have a standard. So based on a standard, we have at least 10 main categories of well integrity standards, which each of them, for example, first one is well integrity and process safety. So they put the well integrity standard related to process safety. It's the main one because it's talking about the process. I mean, the process of well integrity, not the process of, for example, oil and gas. It's process of well integrity. Then you have about well control, well design, I mean, system, a workover, about abandonment. It's a special chapter, drilling operation, production, and finally about carbon capture. As you can see, we don't have any chapter about geothermal, which I will cover it in the next slides. It's very important. This is one of the biggest challenge we have, that there is no special chapter for geothermal in the well integrity standards. As I said, this is also its standard. A lot of local regulation. I can share with you if you need anyone, but there is a lot of local regulation. For example, Saudi Aramco has its own local regulation based on the country system. They based on their listen and learn, based on their experience. Some of them are can apply to other locations. Some of them are not. But when we say it's standard, it means you can refer it as a standard uh, along the world. And there is a very famous sentence: a standard is nothing when nobody refer to it. So if you don't refer to any standard, that standard doesn't worth anything. So you should go through a standard. You should define your standard and focus on it, stick to it, and do it through the whole life cycle. Okay, based on as I said, DO10, its barrier concept philosophy, which has a definition. Well barrier is which is different from barrier envelope. I will discuss more. Is a combination of several barrier elements. Barrier elements. What we talk or you hear among these documents, if you go through a company, mostly they talk about barrier elements. For example, Packer is a barrier element. Casing is a barrier element. Cement is a barrier element. Wallhead is a barrier element. Barrier envelope is a combination of several of these to make a pressure vessel. You can see in the picture, you have a red and blue. The blue is primary well barrier envelope, for example, which includes cement, casing, and, for example, wellhead. The second well barrier envelope is including, for example, formation, surface casing, formation fluid, BOP, whatever. It's different. To just for your information, we have different life cycle. In each different life cycle, the primary and secondary barrier may be different. Okay, so if some barrier is primary in the, for example, well design or drilling, it can be secondary barrier in the production life, or, for example, again, primary barrier in well abandonment, because it's completely related to the life cycle of the well. But you should be sure about the envelope, not about elements. Okay, it's very important. Most of people knows about elements, and this is a difference between engineer view and manager view also. In the standard, you can see barrier elements is related to engineering. For example, you should have some people who is expert in packer, who is expert in casing design, who is expert in cement design and cement operation. But also you need a manager who is familiar with all of them and think as an envelope, because envelope will reduce the risk of formation fluid production, not the element itself. If elements fail, still you can have a envelope which is integrated. Okay, it's different. In this DO10, at least there is 62 barrier elements, as I mentioned some of them, but depending on different standard, they may be more and less about these barrier elements. As I said, based on regulation also depends. For example, in some countries they need to do, for example, two 3SV, but some regulation needs just one 3SV. Based on DO10, at least you need two barrier. It's a shall. Also, there is a difference in shall and should in the standard. Shall means you must do it. Should is a recommendation. So two barriers is shall. There is one important point that primary and secondary barrier must not follow same failure mechanism. Why is that? Because if you consider two barrier and both of them are failure by one mechanism, so you will lose the integrity at the same time, which is not based on a standard. This is one of also the main challenges of geothermals, because in geothermal, the temperature increasing will focus both primary and secondary barrier at the same time. This is one of the biggest challenge, because why we have what we have now in the oil and gas, we based on this standard, they are different. I mean, if the primary barrier is a failure by pressure, then secondary barrier should not failure by pressure. But in geothermal wells, the temperature is affecting both of them, and this is a very big challenge. Also, just the last one about the barrier type. As I said, these barriers, we have different classification. For example, primary and secondary, temporary versus permanent. For example, some barrier are like plugs. You do temporary plug, but you do also permanent. Cement is permanent. Casing is permanent. Wellhead is temporary. The main one is that this philosophy, this DO10 is risk driven. It's focused on risk, and this is a very interesting part of this standard. It's based on risk. It's a risk management system. And if you don't know about the barrier or you misunderstand them, there is false confidence. Why is that? Because if you cannot understand which is the primary envelope and which is the secondary envelope, and you don't know which one is element and which one is not element, then you may think the wall is integrated, but it is not. Okay, so you should know about the barriers. And as you can see, this is based on the definition: technical, operational, or organizational. It is a picture from the standard. It's from the ISO standard, but based on my idea, you should behave it worse, vice versa. I mean, you should go from organizational to operational, then to technical. As I explained, you should first hire people, make them train, expertise, and then those people define the operational procedure. And then, based on the operational procedure, you should choose your technical equipment you need. So the process is vice versa, but for sure, from reservoir to environment, you should reduce the risk. In any way, you should reduce the risk. And then another important point, you should know that not all barriers carry the same weight. And it also depends on the life cycle. For example, cement is different from casing. In some regulation, for example, 200 meter of cement is okay based on, for example, bond index. But you should run the casing from surface to the TT. So the weight of each one is different. And it also depends on the life cycle of the wall. And the main slide about the wall integrity is this slide, that wall integrity is a risk management system. Wall integrity is not a checklist, which most of companies, unfortunately, because as I said, I consulted a lot of company. Most of them, they think wall integrity as a checklist. It means in the in say some specific time, for example, during drilling or production or during the commissioning or well abandonment, they come to the well, make a checklist, then check boxes. This is okay. This is okay. This is, and the wall is integrated. It is false. It is wrong. It is not true, because well integrity is a continuous cycle, and it's risk management system. As I said, the definition, it's defined, the well integrity is defined to reduce the risk. So you should behave it as a system of risk management. Okay, it has core principle which should be risk based. So when you want to design a well integrity system for your organization, it should be risk based, not checklist based. First, should cover full life cycle. I mean, from the designing till the abandonment. And just for you to know that in geothermal, we don't have abandonment. The abandonment is starting a new well. So we will talk about. Then should cover the full life cycle. Then should define acceptance criteria for each envelope and each element. This standard, this management system should include all the acceptance criteria, and the most important one, decision must be defensible. What does it mean? It means engineer doesn't make decisions. Okay, engineer talk about the elements, manager should talk about envelope, and they should be confident that this envelope is integrated. So their decision must be based on some some standards. Okay, and as a cycle, this is the whole process. You can see, you can start it, you should start it actually from assessment context. Assessment context means, for example, a casing. You want to talk about casing. Then you should identify the risk, you should analyze the risk, and you should evaluate the risk. This concept, identify, analyze, and evaluate, they have a standard definition. They are different. They are not the same. In many companies, they behave them as the same process, but they are different. Identifying risk differ from analyzing risk and different from evaluating the risk. And after that, you should monitor it and do some risk reducing measures. Then based on that, you should do some lesson and learn, then go to the next cycle to again assess the context, again identify the new risks, what we did, for example, if we counter a risk, what we did to reduce it. Is it acceptable? Is it successful or not? And if it is not successful, why it is not successful? You should redefine the risk. So it is a continuous process, which is risk based on risk management. And in this risk management cycle, you should consider all stakeholders. Okay, all stakeholders. It means you should consider environment, you should consider people, you should consider equipment, you should consider client, you should consider the regulations. So because of that, well integrity management system is a complicated system. As I said, I want to make it simple, but unfortunately nowadays, if you go to any company, they talk about, for example, AI. Okay, we use AI to do some well integrity management. AI is not capable of doing what I said. Okay, AI is a tool. AI is a tool. It's not a system to help you. And another important point is that without this system, I mean, without risk management system, diagnostic increase uncertainty. What does it mean? If you don't have system, then you just do logging, you just do intervention, you just gather data, and because there is a lot of data, you cannot decide good. There is a lot of uncertainty. This is a mental process. This is based on research. This is a mental process for all human beings that when you have a lot of option, this decision will be made. The decision making is very hard and very difficult, and most of decisions are wrong. So first you should define the system. Based on the system, you should do the, for example, evaluating the risk. Based on those evaluation, you should choose the right decision. Okay, let's go to the geothermal. I just give you a brief introduction of well integrity. I hope you know that well integrity should be managed as a system, as a risk management system. So I will go to geothermal, and at the end of the slide, I will combine both geothermal and well integrity. Geothermal, as you most of them is knowing, is a renewable and sustainable energy source. It's a very new concept. The main capability of that is that reducing carbon footprint. It seems geothermal is to save our life. You know, I think at some time the planet and the earth think, okay, this human uh, cannot save me, so I should show them the way they can save me. So the planet want to save itself by this geothermal energy. I think it's I hope actually. I hope because it's cleanest one about power generation is 24/7. As you can see, the solar energy at night we don't have it. Wind in some area is okay, in some area is not. But geothermal is okay for whole the world. Actually, maybe also is some kind of justice because in every world, every place in the world, if you can drill a well to reach the geothermal, there is capability of you to produce energy. For sure, you need some technology, but still you have it. It's different from oil and gas, which some area has it and some area doesn't. So let's go to geothermal energy. Let's accept this energy from the planet and let's behave it to save the planet and make human being more healthy than now because a lot of issues we have. What will be the future of geothermal energy? This is from the International Energy Agency report, which published last year, actually. Now it's 2 years, but it's last year, actually, 2024. I really recommend to everybody who is interested in geothermal to go through this report. It's very comprehensive report and a lot of good idea. It's as they evaluate it should be it can up to 800 gigawatts globally, which is very very large, very very big. So it can save, as I said, serve a lot of people around the world, and it will be good. It have a strong synergy with oil and gas skills, and nowadays we have to use oil and gas skill, but for sure it's different discipline, geothermal with oil and gas. But because they found that you can reuse oil and gas well as a geothermal, so still related to oil and gas. But I think it will be in the near future. You have different university, even different courses, different university, especially for geothermal, and its critical role in expanding the wall policy support. I just mentioned this item for you. Next generation will meet 50%. It is very important. It's up to 50% of global electricity demand growth. So it's very important. It's very important. As I said, it's very new concept. I highly recommend everyone to go through this one. If have any knowledge of this, I can support. But it's very important. It's very important to do this because it's very healthy. It's, as I said, very lowest carbon footprint. But we need technology. We need technology to do, and we need knowledge also. Both knowledge and technology we have is related to oil and gas, but we need to develop new one. And just to have an idea about the geothermal, we have main type of geothermal energy. You can see in this picture BTES, borehole thermal energy storage. One and two already used. I mean, not already. I mean, maybe 40 years or 30 years are used. Three is more newer, maybe 20 years, aquifer thermal energy. What we talk about geothermal energy now is made of four and five. Four is we call it also conventional geothermal energy, also hydrothermal energy. It means you can find, for example, some formation which is geothermal, then you drill them, produce them, and make some heat. But the new concept is enhanced geothermal system, which you can see as the five in the picture. EGS is the new one. I mean, they have some well. This is geothermal. You inject cool water from the surface, then produce high temperature water. I mean, boiled water to make electricity and power and warm. I know everything, energy, mainly energy. This is the new one. The five is new one. They want to reuse oil and gas well as this five. So because when they do some research, they found the main cost of the well integrity, well, the geothermal energy is drilling a well. So if you want to reuse a well, oil and gas well, so the main cost, which is drilling, is removed. So it's more economical. But but the big problem is that oil and gas well designed for oil and gas, not designed for geothermal. So not every well is okay for geothermal energy. You should choose some of them, you should modify some of them, or you should drill new wells for geothermal. And just for your information, this picture is from TransGeo project. They did it in Netherlands. Just energy potential of each one. I can share with you the slides, or you. I think you have the video because of the time limitation. I just passed through, but you can go through this information. Everyone has the different capability of making energy. As you can see, the mega electron world, HE and EGS is the most important one. Okay, why geothermal is not oil and gas? Okay, as you can see, we are dealing with another world. Why is that? Because geothermal formation are characterized by some specific characteristics. It's like high temperature first. In oil and gas, when we say high temperature, it means a small percentage of the wells. Uh, just to give you an idea, in oil and gas, when we have for example, handbook of everything, for example, reservoir engineering, production engineering, drilling, exploration, whatever, what discipline, is this book is 400 pages. At every pages cover the oil and gas. At the tenth of the end of page, I mean 10 page of the end, you should see the some concept of high temperature, high pressure. But when you talk to geothermal, in these 400 pages, from the first page till the 399, you talk about high temperature, high pressure. And at the end of the page, you should talk about the reference just. So this whole difference is high temperature. And when we say high temperature, we say very, very high temperature. Because in oil and gas, when we say high temperature, we mean 200 C. But in geothermal, 400 C is normal one. So this is completely different. The next one is thermal cycling, which is the biggest issue related to temperature. Uh, you know, High temperature is a challenge, but thermal cycling is the more dangerous challenge. Why is that? Because during production, during drilling of a well, even geothermal well, you have mainly 100 C because it's not production; it's just drilling mud. When you go to the production, you have 400 to 600 C. So this big difference between the production and drilling, and then if you want to shut in the well, then re-inject it, it's a lot of cycling, which damage cement, which damage casing, which damage surface facility, everything, because they are not designed for conveying thermal cycling. Then abrasiveness, which is mainly from this water production. They have solids, they have corrosive, they have high compressive strengths, the formation, I mean. They have high permeability. What does it mean? They have high rates. So, as I said, oil and gas defined, for example, to 100, 200, 1,000, 2,000 barrel per day. But we are discussing about around 20,000 barrel per day of water production. So it's completely different. And they are good heat conductivity. So what does it mean? It means if you run a casing from this temperature increasing is very, very fast, so it doesn't let you to make it equalize the temperature. And this is a big challenge for logging tools, because these logging tools, when they go down to the well, they should consider the temperature, for example, from surface temperature till 600 C temperature in 1 hour, and this is high. And also there is corrosive fluids with high solids. So what we avoid in oil and gas industry, all there is in geothermal for fun. So we have all of them, but in oil and gas we should avoid. But in geothermal, you don't, you cannot avoid, you have them. So, as I said, everything we have now is oil and gas. The skill is oil and gas, expertise, technology, tools, equipment is oil and gas. And oil and gas are not designed for these conditions. They are not for design for high temperature, for temperature cycling, for good heat conductivity, and for these corrosive fluids you have. And why oil and gas logic is failed for geothermal wells? Because we are talking about different time scale. As you can see in this picture, this is to my favorite Bollywood star, actually Amita and his son. You can see the Amita is geothermal. Why is that? Because when we talk about geothermal, we talk about centuries. Oil and gas, we talk about years and decades. Okay, so this big difference. And as I said, as I said, because technology is designed for oil and gas, they are not designed for centuries. But geothermal is to the end of the life of the planet. So if you want to drill a well for geothermal, you should consider centuries. Okay? Geothermal failure are temperature driven, but most uh, oil and gas failure are pressure driven. This is another difference. And as I said, thermal cycling affect everything, casing, threads, wellhead, cement design. This cement we have also designed for oil and gas. So they cannot tolerate this thermal cycling. They cannot tolerate this high flow. They cannot tolerate this age, actually, because even in oil and gas, when you do logging in a well, after 20 years, the cement is degraded. Why? What happened if we talk about century? If we talk 100 year? And also corrosion degradation models. This is one of the main research area now they are doing. Uh, the model we use in software for temperature for oil and gas are not temperature based actually. So we need to do some new models for temperature based corrosion and degradation models. Okay, what is the primary challenge of geothermal? If I can say it, this is this is by me actually. It's my idea. Anyone can reject it, anyone can accept it. Because there is no globally accepted standard for geothermal well integrity, this is the primary challenge. And why is that? Because if you know that for each standard in oil and gas, we pay a high cost of explosion, which is the last biggest one was Macondo. You know, most of the standards, I think all of the standards are, how can I say it, are born after explosion, after accident. So I hope we learn, we develop a standard for geothermal without any accidents. I'm not sure because if there is accident, for sure there will be blood. For sure, there is not explosion like what you see in this picture because there is no oil and gas to make fire. But there is very high temperature. Your safety in the surface, I mean, even your firefighting system, your surface system are not designed for this high temperature. So if there is a blowout, nobody can manage it. Nobody can manage it because it's high rate, it's high temperature, and the facility we have to fighting this blowout is designed for oil and gas. So I know there is some organization, there is some institute are developing the standard for geothermal, but it's too slow. I hope it's make faster. We need it because to have a globally accepted and everybody can follow it because now it's not globally the wells, the geothermal wells, but we need a standard before drilling the new wells. What about the technical integrity challenges? You can see the degradation of drilling and completion fluids because, as I said, most of challenges is that because we think of oil and gas, and then when go this technology to geothermal, there will be challenges. Drilling and completion fluid are not designed for this situation. Fluid property variation for this temperature, as I said. Cement strength, because as I said, even for oil and gas, after 20 years, cement will be degraded. But for 100 years and this high temperature and this cycling is damaged. Casing expansion, which is show you in next slide, buckling and decoupling of casing corrosion, wellhead thermal expansion, and scaling. Most of these challenges are rare in oil and gas, but it are common in geothermal because of these properties, this specification, and these characteristics of geothermal energy. You can see this is a challenge in Netherlands. Uh, I can assure you that this challenge will never happen in oil and gas, but it's happened in geothermal well. You can see it's 20-inch casing and 1338 casing inside. The water as you can see in the last picture, the water expansion because of the high temperature parted this casing and its integrity failed. You can see this water expansion. It will never happen in oil and gas. So when you want to design a well for geothermal, you should also consider this situation, which in oil and gas you don't need it. As I said, it's very big challenges. You're reusing oil and gas wells for geothermal will have some limitation. Uh, Drilling new well which have high cost. So you should find an optimization between high cost and also reusing the oil and gas wells. So the key geothermal consideration based on this data I mentioned, it's well design, casing design, drilling fluid design, completion fluid design, and cementing design. And the finally one is proactive monitoring. Each one has different slides because of time limitation. As I said, the webinar is time limited. We can manage another webinar if possible. However, I can go to detail. I just go through them fast. These different criteria, these different elements, you should consider them because of this limitation I said. For example, in well design, you should consider casing seat selection is different from oil and gas. I mean, the casing point is different, the depth consideration is different, wellbore stability is different because you should consider thermal insulation. Why is that? Because in oil and gas it doesn't matter. But in geothermal you should deliver the energy from bottom hole to the surface. This energy is temperature, so you should think of insulation, thermal insulation. So the most of energy cannot dissipate into the formation again. The most of energy you should recover it at the surface. So you should think of insulation. Why should insulation? Like for example, you need different casing design, different material, different cement material, different coating material, different completion fluid material, and you should consider all of this because they are different from oil and gas. About casing design, you should consider material selection. You should consider about casing thread. Very important, because one of the most failure in the casing is about thread, and the thread mostly affected by thermal cycling. So this design we have, I know, for example, one top, which is a famous one for premium thread inside oil and gas industry, they developed a new thread, one top HIC, something like that, for geothermal. So because it can tolerate this thermal cycling. Casing coating consideration, as I said, because the scaling, the corrosion, and also the temperature insulation, and also the installation is different. Installation is different. The drilling fluid design, you should different mud weight, as I said, because the rheological properties, because of this high temperature, and also the time limitation. After the casing to the next hole, you have time limited. Okay, you should do a better mud weight window, because if the mud is not good quality, there is a challenge, there is a risk of explosion and blowout. Also, laboratory testing. So the laboratory equipment we have is not good for this high temperature. They cannot test actually. So if you can see there is a wide range of technology you need for geothermal. I mean, from laboratory testing till the operation, till the logging, until everything. Mud cooling equipment, what does it mean? Because when you go down the mud will experience 400 C. And then this mud come to the surface, you should cool it to reuse it. So cooling system also different. I mean, the drilling system is also different. And completion fluid design, just as a information, what we commonly use is brine solution, inhibited water, polymer solution, organic ester. They have different capability based on the application. For example, polymer solution, they have more weldable stability. They can fluid loss. As I said, most of geothermal formation are high permeable, so there will be a risk of loss. And also cementing, which is one of the most important, because cement is one of the main elements of well integrity. So if you lose the cement quality, you lose the integrity of the well. And as you know, the Macondo happened because of cement quality. So the cement quality is one of the most important one. I know in, for example, Canada, I think British Columbia, they are mainly focused on cementing design for oil for geothermal, and you need technology to evaluate it. This CBL logs we have is not suitable for geothermal wells evaluation. And about proactive monitoring, which is related to digitalization, let's go to that. For sure, if you have the data, if you have more data, I mean, proactive monitoring, it will help you to reduce the risk. So you need real-time data analysis because they give you early warning system. As I said, because it's managing blowout in geothermal is more difficult than oil and gas. You need high temperature logging tools. This log you can see is from a scientific drilling company. They are located in Netherlands. They have logging tools till 300C. It's very high. They can do logging. Okay, but still not all logging tools are designed for this wells. Just well integrity log, multi-finger caliper, PLT, and temperature logging. I think is designed for high temperature. But you needed wireline cable is also important because there is no wireline cable in the world now who can tolerate, for example, 400C. Vacuum flask housing technology, which is the technology to increase the temperature rating of the logging tools, but they have time limitation. For example, they can tolerate 300C in 1 hour. So you need to increase this technology, as I said, logging time duration. So what's important of digitalization? Actually, digitalization, when we say digitalization in the oil and gas industry, we're talking about technology, but digitalization is about the organization. Okay? The main concept is about the organization. If your organization is not digitalized, using digital technology is not helping you. So first, your organization should be digitalized because this is one of the most important point I want to deliver you during this webinar. That digitalization is an organizational barrier. Okay? Refer to the first slide based on DO10. As I said, well integrity, it means technical, operational, and organizational to reduce the risk of uh, explosion, for example. One of the main elements of organization is digitalization. So if you want to make the most important barrier to well, to geothermal, to oil and gas wells, you should digitalize your organization because this digitalization will give you some real-time data, some monitoring, some decision making, some procedure which you can forecast the problem and you make remedy before they happen. So think of digitalization as a barrier. If you think like that, then it will help you. Okay, it will help you to manage. But if you just think it as a technology, this is technology. I can, for example, use fiber optic. I can use, for example, platform. I can use whatever, AI. They will not help you till your organization is not digitalized. And digital monitoring is not a tool set. As I said, it is a philosophy. It is an integrity philosophy. Okay, it should give you continuous measurement. It should help you to define a strategy for whole life cycle. Okay, it should give you data integration across the barrier because itself is a barrier. Digitalization is the most important barrier during this area. And for geothermal, as I said, because already surface facility is not designed for high temperature, you should digitalize them to support decision making, not data collection. As I said, without any system, data collection just increase the uncertainty. And the last one, integrity must be managed proactively. Proactively. It means you do permanent monitoring, you do logging based on procedure, you do logging based on standards, and digitalize them, make decision before anything happen. And if you can go to the role of digitalization, if you can see, this is a well integrity management system. You can see it. The first one is real-time monitoring. if you want to design a management system, you need real-time monitoring. So how digitalization can help you? It can help you continuous monitoring, pattern recognition, predictive integrity mindset, acceptable risk based on lesson and learn, based on the history of the production, align engineering decision, because as I said, you should provide decision by engineer and make decision by manager. Enable consistency between the organization, then logic required. We need new logic. As I said, we need a new philosophy for geothermal. We need a new philosophy. And the last slide, which is the future trend, maybe the some research point. So I tried my best to cover whole webinar. As I said, it's time limited. First, we need a geothermal specific philosophy. As I said, there is no globally accepted standard because still the most mind of people is oil and gas mind. They are not geothermal mind. So we need a new philosophy, new design, new mindset. And then we need dedicated geothermal standards. For sure, we can use oil and gas standard as a basic to develop them, but we cannot use them wholly. Then we need digital twins. We need AI assisted interpretation. Why is that? Because as I said, we have technology limitation for geothermal for high temperatures. So you need to AI assisted interpretation to use all the data, to use models, and then you need integrated management system. You need logging tool development, as I said, because monitoring is the main elements of a well integrated management system, and you need defined degradation mechanism, as I said, based on temperature cycling. You need different life cycle expectation is completely different with oil and gas, and you need active international development. As I said, planet give us this geothermal, but we should behave as human, as integrated. So we should make sure that all the worlds, even oil and gas and geothermal, are integrated. Digitalization is a tool set. You can use it. You need a new philosophy and new standards. Thank you. I tried my best to cover. As I said, you can connect me through LinkedIn. Every question you have, you are most welcome to ask me. I will here to support you in research, in whatever you have. Again, thank you for this IITG to arranging this webinar. Sorry if there is anything missed. I tried my best. I'm here to cover your Q&A if there is any time. Okay, guys.
Hello, sir.
Hello. Okay.
Thank you, sir. It was a great session, and I will ask everyone to ask any doubt or any question on this topic.
Yeah, hello, sir. It
Hello.
was a nice presentation. Really, I am from oil and gas industry. I didn't know about much more broad thing about the geothermal, and you have explained all the thing. But I have a question that how we can find out the early warning system in geothermal, because there is always because this is a high temperature, high pressure well, and all the things like casing, cementing. There are different problems in the geothermal reservoir. So how we can like how we can connect our prepare our early warning system.
Okay. Thank you for this question. As I said, also from your question, I can see it. As I said, we need to define new philosophy. Still, all of mines are oil and gas. Okay, I believe you because, as I said, most of technology we have, most of monitoring system we have are related to oil and gas. They are not for this high temperature. Even the models we have, I mean, the
Yes.
system of interpreting we have. That I said, you should do early warning system because you need. I think, for example, in ADNOC and Saudi, they use some
Yes.
geothermal They have some technology that is patented, it's not published, but they define new models actually
Yeah.
based on, for example, temperature, pressure, because the signature, I mean, the sign of problem in geothermal is completely different from the sign of problem in oil and gas. For example, in oil and gas, when your pressure goes up or you see an increase in temperature, is sign of problem. But here, it's normal. So, as I said, we need to define new models, new mechanism based on
Yeah.
that mechanism. For example, what does it mean? Temperature, it decrease, does it mean anything? In some cases yes, in some cases not. If the production rate goes high, what does it mean? You can go, for example, as a AI system, do some
Yeah.
history matching, find some new model, some new behavior system of this model, and that based on that behavior you should find some warning.
Yeah.
Using oil and gas technology, no, you cannot find any warning, early warning system actually.
Yeah. Okay. Thank you, sir.
Okay. Hello? Hello, go on. Yes. Oh, okay. There is some criteria. Some criteria. I think maybe we can manage a webinar for choosing geothermal area or walls or whatever. They have a published map. I don't know for India they have it or not. Uh, I, I think there is. I think there is. I think I saw it sometime. They have some published map from this International Energy Agency, for example, or some researchers. You can go through them. Based on that geothermal map, you can see where is the best temperature you can find in the Earth to drill. Okay, but this is just a geothermal map. I mean the energy map. But choosing an area to do drilling for new geothermal well or reuse of uh, oil and gas well to do geothermal is different concept. For example, if you want to drill a new well, first you should do some reservoir modeling. It's very complicated modeling. I think just some few organization and some few university I know. For example, in Italy, in Netherlands, and in UK, there is three university they are doing this modeling. You should have some reservoir data to do some modeling. Based on that model, you should find how many, for example, power you need, how many power you should generate, and then do economical analysis. Based on that economic analysis, you should find it's economic or not. Then you should go to find the technology. Is this area you have the best technology to drill a well or not? So at this time, you have mostly you have limitation of technology, not limitation of the earth, because everywhere in the world, as I said, less or high, you can drill a well to find a geothermal. But is it economical or not? It's a question. If you want to find it economical or not, you should do some first reservoir modeling, then technology analysis, then economic analysis, and based on that, you should choose the uh, best area. But if you want to reuse the well, those main consideration I told you, that for example, casing selection, choose the casing, choose the cement, choose the select the mud, different criteria. That's six criteria actually. You have to reuse the oil and gas well. Yes. Yes. As I said, yes, yes. First one, if you want to use AI, the best one is the selecting the well candidate. Okay, the best one which now in the world use is select a candidate. But I think for well integrity, because about last month, not last month, about yes, in November 2025, there was a conference in Netherlands. The name is it's workshop actually, future of well integrity. Okay, the main concern was that the AI is not well used in well integrity. Okay, it means every company he say, well, I used AI, is just something like show off, like business view. Technically, I think there is still potential of using AI in well integrity, mainly in proactive monitoring and also in decision making. Because when you want to make decision, you need to know all the standards. Okay, and if you can design an AI system, to be honest, I already designed with the one. It's not published, it's just personal use for me. I will try to publish it. It's based on, I think, all this 150 standard and local regulation. For each case I want to use as a decision making. For me, actually, I want to do decision making. So if you want to use it in India, go to the decision making system using AI for geothermal.
Hello, sir.
Hello.
Hello, sir. Firstly, thank you for your presentation. We had a very good insights on geothermal well integrity and digitalization. My question is that we got to know that many aspects are different from the oil and gas industry here. But now, should we firstly focus on the technical aspects of this geothermal area, or should we go to the like how to explore more? Like, should we go on the exploration part firstly or the technological part firstly, sir?
Okay. As I said, based on the standard definition, I prefer first you should go to, I mean the international, not personal you or your system. First, we should train people. We should increase knowledge of people about geothermal. Okay. Then these people we should define a standard, globally accepted a standard. Based on that, then go to the procedure. Then based on that, go to the technology. Okay, because developing a technology needs some infrastructure, but for people you need just training. So if I want to recommend you as a personal, go and study and read some standard, some oil and gas standard like the O10, as I said, or other standard. Then find the problem you challenge, the challenge you have in geothermal, which is not covered in the standard. Okay, so you find some elements. Okay, for example, this is high temperature, which is not any sentence in any standard about this one. Okay, develop a concept for that one. Okay, then if you develop a concept, you can go to a technology provider that said, okay, there is a challenge in oil and gas, there is no solution in the standard. I find a solution, and you can make it as a technology. I think this way you can go to market. I think the market wise view. So read the standard, find the challenges, find those points standard is not covered, find some solution for them, go to technology, find the gap, and go to the market.
Thank you, sir.
Any more
Okay.
question?
Yeah, good morning, sir.
Good morning.
So, I am pursuing my uh, graduation in chemical engineering only. I'm working in artificial intelligence for the field. So, to proceed further, I would like to have your opinion on how should I proceed to tune my skills and to develop my further skills and seeking guidance towards petroleum engineering only. I went through your LinkedIn page. It was very captivating, but I don't have much information about how to proceed well for that kind of exposure in my life.
Okay.
So it would be
You
great
know,
if you could guide me.
okay, okay. I get the point. At some point, maybe 1 year ago, I put a post on LinkedIn that if you want to use AI in petroleum engineer, first you should be a good petroleum engineer. Okay. Now I can say, because when you want to apply AI in the well integrity or in the oil and gas or geothermal, it was system, you should know this system. Okay, because if you don't know the system, you cannot find the problem, you cannot find the issue, and you cannot find the solution. So the first idea for you is to work as a team with, for example, some other guys. What you need to know, just a formal, general familiarity with oil and gas or geothermal. I not recommend you to go to oil and gas because there is a lot of people around the world and the market is red already. Okay, I mean a lot of people who is working in AI in oil and gas, but geothermal is new, and AI in geothermal is also new. So this webinar, as I said, geothermal, well integrity, and AI. If you combine all of these two, will be the newest concept in the world. So I recommend you to make a team. You, one guy who is expert in oil and gas, one guy who is expert in well integrity, one guy who is expert in geothermal. And based on these four guys, you can develop a team. As I explained to a previous question, you should know the first, you should find the gap between the what we have in oil and gas and what we need in geothermal. Okay, as I said, one of the biggest challenge is decision making in geothermal, because the time limitation in geothermal is much more less than in oil and gas, because the high temperature. Okay, even the logging tools, for example, logging tools cannot tolerate 300 C for more than 1 hour. So what if we have a system, AI driven system, who can predict the data based on that 1 hour data? Okay, you can gather 1 hour data, but you can make decision for example, 2 years. This should be done by AI. Okay, as I said, one of the main application of AI is pattern recognition. So why, if you can find some pattern in oil in geothermal wells, even in location, even in the depths of reservoir, even the casing seat selection, mud window, I don't know, formation fluid, cement evaluation, which is very important, which is important. For example, these tools we have already is for normal cement. If you want to use a specific cement for geothermal, is this tool still valid? I'm not sure. I'm not sure, because high temperature may influence the amplitude and the frequency of the sonic waves. Who knows? So this area is very open to use AI in them. But for sure, you need some knowledge of geothermal and well integrity. And for that, the shortest way is to have someone in your team to work as a team. Okay.
Chitra, hello.
Hello.
Yeah, sir. Thank you for the clarification. I was meaning to apply for such an opportunity. So, how should I proceed with that? Like,
Okay, okay. I did. Okay. If you apply for such an opportunity, now the best market is around the Middle East. If I rank them, first Saudi, then Abu Dhabi ADNOC, and then Qatar Petroleum or Qatar Energy. Because during last 3 months, There was some options. They called me to find some people, but you can find it maybe on online. But if you want to apply for these three, as I said, Saudi Aramco, ADNOC, and QP or QE, Qatar Petroleum, Qatar Energy. This is very open to use AI in oil and gas and mainly in geothermal because they are already started. Saudi Aramco is the biggest one. First, you should cover your LinkedIn actually because these guys, I know these companies, after receiving some CV, they go to the LinkedIn, to your profile, and see if you are active, what's your main expertise, what's your main profile is about. So first, at least 3 or 4 months, put focus on your LinkedIn page, okay? Then, based on what you want, first go to these websites, Aramco, ADNOC, and QE, and see what is their career. For example, if they mention they need AI in well integrity, if their main recent research is AI, for example, in geothermal, then you should cover your LinkedIn for the next 3 months on AI in geothermal. Then after 3 months, you can go send them some CV, or you can find them on the LinkedIn. Because I know these guys have some department, they search the LinkedIn profile to find some people. Then, if your LinkedIn is active, based on their LinkedIn, they will invite you to interview and you can find some opportunities. I know there is a lot of Indian guys already in ADNOC and Saudi Aramco. Also, you can use them. I mean, you can connect them because they are Indian, so they are good with you for sure. You can find them on the LinkedIn, connect them, give some idea from them, get some idea from them, and do this. So put focus on your LinkedIn and the career you want based on these three companies if you want to work in Middle East. For Europe and US is very difficult at this time, but these three countries, as I said, is very open.
Thank you. Thank you so much, sir. Thank you.